To stage Gopika Subramanian. Hello, Gopika.
Hello, nice to
How are
meet you.
yes,
Yeah,
and you? How are you?
I'm good. I'm good. What
How?
about you?
Yes, very well, thank you. Very well. And where are you calling in from?
I'm from India, Kerala actually.
Kerala. Okay, excellent, excellent. So you're talking about is it Quines or Quins?
Coins. Yeah,
Quines.
coins.
Okay, and it's SQL injection, right? I know that
Yeah.
much. Yeah, there
Uh,
we
yeah.
go. There we go. Well, I mean, SQL injection has been around for about 15 years, right? So I
Yeah,
must know about
it's
it.
so long. Yeah.
It's in the OWASP top 10 forever. So, um, okay, so Gopika, please get your presentation up and
Yep.
ready. In the meantime, can I just remind everybody the left of their screen, no, that way, the left of their screen, I'm going to rephrase that again. The right of your screen is where the comments are and where you can place your questions. If you have any questions you'd like to discuss later on, please jump onto the Slack channel where Gopika, I hope you'll be able to jump into the
Yeah,
Slack
sure.
as well.
Yeah. Yeah, sure.
Fantastic.
So is my
So,
screen being shared now?
yes, it has.
Yeah.
You
Okay.
are ready to go. Take it away, Gopika.
Okay, cool. So hello everyone. I hope everyone is safe and secure. I'm Gopika, and today I'll be doing a presentation on Quines and Quine SQL injections. So I think the topic Quines, a self-producing syndrome itself, is making it pretty self-explanatory. But again, let's see. A little bit about myself. I'm bachelor in technology student at Amrita University, Amritapuri, and I'm an avid CTF player of Team BIOS, which is the number one CTF team of India, and also the member of Team Shakti, which is one of the three women-only CTF team in the world. I focus on web exploitation and web security. We are also the hosts of Shakti CTF, which is an upcoming CTF for women, and various other cool CTFs. Okay. So, as I mentioned, our team is ranked number one CTF team in India, which started in 2008 by our mentor, Vipin Pavitran sir. We take upon security researches, vulnerabilities, and its mitigations, and so we are the host of InCTF International, which is pretty popular. InCTF National, which is like the national level CTF for college students. Then it's like the first one in India. And InCTF Junior, which is the national level CTF for school students. Okay, a little bit about Team Shakti. Team Shakti is a women only CTF team. We started our team in 2018. We conduct workshops and other programs to bring more women into the field of security. Yeah, as I said, we have an upcoming CTF exclusively for women. Cool set of challenges. Okay, so let's look into the agenda of today's talk. So, starting off, personally, I feel like I prefer more examples and demonstrations than theories or definitions to understand the concept. And I'm gonna make this beginner friendly as much as possible. So, I'll start from the basics and increase the level. Okay, so I'll begin with a briefing on SQL queries for those who are new to it. Yeah, I'll brush upon the syntax and how the queries are used to manipulate the database, add, delete, change, and so. Then I'll give a quick explanation on SQL injection, since without the basic concept, it's going to be really difficult for me to explain what I intend to, just for my satisfaction. I'll explain a bit on what SQL injection is, like how it happens, why it happens, when, and so on. And then what are the types of SQL injections? We will check a few examples for clarity. Then we look at a few prevention methods. And also, yeah, the cool thing, we can see, like, check a bit on the bypass of web application firewalls with SQL injections. Okay, so for those who already know this, hold on patiently because I'll be taking a short SQLi 101 before getting into Quines. I want to make sure things are presented clearly to each and every audience. Okay, so next we'll get into Quines, practically what, how, when, why, and that sort of stuff. What is the whole purpose of Quine? Like, how it is interesting. So it's like something about Quine. It's what Friedman said. It's like Quines are practically something that popped out of biology. Okay, the whole concept. So unless and until you look at it in a curious perspective, it's actually really, really interesting and exciting. But it can feel very useless if not understood properly. Okay, I'm being brutally frank here. In the beginning, I was like, what's going on here? Like, what even is the point of it? But yeah, it's pretty fun. Okay, so we will look into the uses and a few examples on how it works, and then talk about injections like in Quine called an Introns. This is not a Quine SQL injection, but a method of injecting in Quines. Finally, we'll talk about Quine SQL injections. It's pretty neat and fun. Again, what, where, how, and all. Then a demonstration payload. I'll break it down into small pieces so that it's easier to digest. Okay, we'll also discuss on the impact, severity of this attack, how it can be mitigated, because that's an important thing, and check a demonstration of Quine SQL injection in a weak authentication check. So the whole prevention part can be understood from the vulnerable authentication check we're seeing in the demonstration itself. Okay, so starting off, SQL is a domain specific language. It's like used in programming, and it's basically designed for managing data held in any sort of relational database management systems. So let's just say we have a login system. You type in your name and password, and in the backend, it fetches the details with respect to the data with the data sent, and it sends back the response. So the mechanism which selects the content where username equal to S and password is equal to Y, that's where SQL comes into play, right? So we have the accessibility to manipulate data, unlike our files, which can be disorganized and less secure when compared to when considering data handling, right? So some common relational database management systems that use SQL are Oracle, Microsoft SQL servers, Access, Ingress, etc. Although most databases like systems use SQL, most of them also have their own additional proprietary extensions that are not only used on their system, like it's like exclusive to them. It's not common for everything. However, there are standard SQL commands, just select, insert, drop, delete, update, create, and all, that can accomplish almost everything one needs to do in a database. It's like manipulation, complete. It's all the manipulation needed. Okay, so the the basic function of SQL is to query data contained in a relational database, as easy as that. And yeah, on the contrary, every functionality comes with a flaw, right? So no method in this world would be 100% efficient. So there comes the attack to destroy SQL functionality. And to all the people who say SQL is old school and not fun anymore, it's sad how they miss the wide variety of the attack. Okay, next slide. Okay, so injections. SQL injection is a code injection technique, yeah, which is used to, attack data-driven applications, which is like very much malicious SQL statements are inserted into entry field or where the input is taken for execution, like the input fields. So yeah, like injection has made a like our host said, injection has made a constant appearance in NOAA's top 10 web application security vulnerabilities for over 10 years. SQL injections, like, it allows an attacker to spoof identity or tamper with existing data, cause reputation issues that could be like voiding transactions or maybe changing balances, allow disclosure of data, in even many cases destroy data, like make it completely unavailable. And there are also cases where they could get a privilege escalation. They could become like administrators of the whole database server. Okay, so as I said, SQL injection must exploit a security vulnerability in an application software. So for example, when a user is either incorrectly filtered for string literal escapes, characters which is embedded in SQL, or use input in which is not strongly typed or unexpectedly executed, or accidentally run or so. It's most known as attack vector on websites, but yeah, it can be used in any type of SQL databases too. Next slide. Yeah. Okay, this is an example. SQL injections vary, yeah, definitely, but mostly it's like using the input and closing the query, running in the back, adding a few queries, and removing off every bit of the rest of the query with commenters. So here we have our inject in red. This is like very basic injection where we inject malicious code in the input, comment off the rest, whatever comes in. Yeah, for those of you who are new to this, I hope that's clear. Yeah, let's go for a short demo. So what's happening here is it's selecting the output where username and password provided with what is provided with what is there in the database. Okay, so it's like normal authentication checks. If it finds the correct one, it prints welcome. Else it prints valid. So here I'm giving the valid ones and it prints welcome. If I give an invalid password or username, it gives invalid. As easy as that. Okay, so let's just say we want to log in as admin to get his or her privileges, and we don't know what the password for admin is. What we do is inject a query which comments the rest of what is there in the backend, rest of the select statements. So finally, it becomes select. It just selects where username is equal to admin without asking the password. Simple as that. That's like very basic form of SQL injection. Yeah, next, getting into the types of SQL injection. Okay, they can be classified into three main categories: in-band SQL injections, inferal SQL injection or blind SQL injections, and out-of-band SQL injections. Okay, in-band SQL injections is usually the most common and easy to exploit kind of SQL injection attacks. Like in-band SQL injection usually occurs when an attacker, is able to, or say, the same communication channel, use the same communication channel to both launch the attack and also to gather results, right? So the two most common types of in-band SQL injection attacks are error-based SQL injections and union-based SQL injections. Error-based SQL injections usually relies on the error messages thrown by the database servers. So if you use MySQL or something, if there is an error, it pops like, okay, there is a syntax error or so, the errors are thrown back. Union based depends on the union SQL operator, which is like the combinational operator. Like, it's pretty self-explanatory. So it combines the results of two or more select statements, right? Okay, in blind SQL injection, it's practically a pretty long down ride for an attacker to exploit. The attacker would not be able to see the result of an attack in an in-band, which perhaps explains blind, as in the attacker closely examines like indirect clues in behavior, like when we try to get an error, fix it, try again, sort of say, trial and error stuff. The injection doesn't reveal data from the database directly. So clues can be like HTTP responses, blank web pages for certain user inputs, and how long it takes, for the database to respond to certain user inputs. Others are the things that can be, clues depending on the goal of the attacker. And yeah, the two types of blind SQL injections are blind Boolean based and blind time based. Yeah, Boolean based SQL injections depend on whether the query returns true or false statements, as the name suggests, Boolean. Yeah, in time based, the query, to the database, which forces the database to kind of like wait for a specified amount of time, and the response time explains true or false. Like let's say wait for 5 minutes, 5 seconds. If it waits for 5 seconds, it's true. Something like that. Okay. Next, out of band. Out of band SQL injection occurs when an attacker, is unable to use the same channel as to launch the attack and gather results. Like, it's the opposite of in band. This is pretty less, common one of the found. Okay, this is the fun part of SQL injection. Yeah, it's like when we get to break the exclusive rules. Like, it's particularly given that don't do it, and the first thing is like do it. So a WAF or web application firewall helps to protect the web application by filtering and monitoring HTTP traffic between web application and the internet. It typically protects web applications from like cross-site scripting, cross-site forgery, file inclusion, SQL injections, and other kind of cool attacks. So as I was saying, a WAF operates through a set of rules called policies. These policies aims, to protect against vulnerabilities in the application by filtering out just the malicious traffic, right? So in applications prone to SQL injections, they tend to create a web application firewall that sanitize or blacklist the common SQL keywords in the input. Okay, so SQL injection WAF is generally same as the policies. It follows a bunch of rules to prevent SQL injections. So most common filters applied by WAFs are bypassable. Like it's easy to bypass. Let's discuss a bit the common ones. Okay, so union blacklists can be trashed by blind SQLs. So it actually uses the method of requesting a true or false statements, as I said before, as the responses from the database using AND operator or operators to brute force the data. Okay, this can be used when the database does not give out any output, right? Next is buffer overflow bypassing. So while writing into the buffer with huge values, surpass the buffer's boundary, like overwriting the memory of an application, because most of the WAFs, right, are mostly written and compiled in C. CRLF is carriage return line feed. Okay, these control characters can be used to substitute for spaces or comments which are blacklisted. HPP is HTTP parameter pollution. Okay, the parameters in the HTTP request is like maliciously, manipulated with maliciously, different unintended malicious statements, methods to achieve sensitive information. It's like, multiple parameters of the same name are interpreted differently in different languages or frameworks as well. So to give an example, PHP or Apache is like considers the last occurrence of the parameter. So if we give username equal to Kim Jong-un and username equal to admin, it would consider the second one. So we get the access of the admin. And if the framework or the server is JSP, Servlet, or Apache Tomcat, it considers the first occurrence. So we swap it, right, to what our requirement is. Okay, so character substitutes. It's like we using characters like parallel, question marks, double quotes, single quotes, percentage, ampersand and all. Usually the WAF would consider these kind of special characters as spaces and completely ignore them. Okay, so which is like help for us to bypass various keywords which are blacklisted, like so be it space and all. Hex encoding, yeah. When particular keywords are blacklisted, we could substitute with the hex encoded value, because after the URL is passed, it obviously decodes and turns the hex value to plain text. Like, okay, so Unicode encoding, yeah. In this encoding standards, like some of the characters can be used as the substitute for ASCII character values if at all it's blocked, and thus we can bypass it and dump the database. Okay, next is base conversions. By base conversion, I think that's self-explanatory. It's like by representing values that are blacklisted in different bases. It's like 0 base 16 and base 8 values are differently printed, but it's the same value, right? So what we can do is represent values that are blacklisted in different bases would help bypass that filter. Null byte injection, yeah. When we provide a URL encoded null byte, which is like %00, before the string to be bypassed, it will remove everything after the null byte. So that can be used as maybe comments, substitute, and so. Next is ASCII substitute. It's similar to Unicode substitute. It's like these ASCII characters can have multiple alternatives which has a different value, but their functions would be similar and can be used to bypass any blacklist that's created, right? Changing cases. Okay, this is not that common, but yeah, SQL, I mean, I don't think servers are that dumb to, keep a WAF that can bypass changing cases. Like, we can bypass with the changing case. So the SQL keywords are obviously case insensitive, and hence when a WAF blocks a particular case of string, you can bypass it by giving varied cases. Right. Okay. URL encoding. It's also similar to hex encoding by substituting hex values to all the blacklisted words and bypass it once the URL gets decoded. Replace bypass. I don't think this is very common, but yeah, the WAFs that replace all occurrences of particular keywords with empty strings can be bypassed by giving a keyword in the middle of the same keyword and hence getting the same keyword after the WAF replaces the keyword in between. So practically these are just a few methods. Like the later is just a huge wide ocean of exploits and methods. Next slide. Okay. Now the pretty mystical one in injections, Quine SQL injections. But before that, what is Quines? Okay, let's get a good idea of Quines before we move on to Quine injections. A Quine is a computer program which prints its own listing. Okay, the concept is actually, as I told, it's from biology. It's actually from cell multiplication concept in living beings, as in molecular biology. DNA replication is the biological process of producing identical replicas of DNA from one original DNA molecule. We got that right. Okay. As in how DNA and other protein stuff is replicated as well as in the new cell. Okay, so that's self-replicating programs. It's similar, like that's what Quine does. That's the characteristics of Quine. This may sound either impossible, trivial, or trivial and stuff like that. Like what's printing its own listing? Okay, what is the point of it? Like this means that when a program is run, right, it must print out precisely those instructions which programmer wrote as a part of the program alone. So okay, let's just say we have a program print hello. So the output is obviously gonna be hello, right? So for Quines, it's like if the program is print hello, the output will also be print hello rather than just hello alone. Okay, the easiest way to do that, of course, is like go seek the source file on the disk, open it, print its content. Okay, what's the use of it? That may be done, but that's definitely not a program which is printing itself. Besides, the program might not know where the source file is. It may have access to the only the compiled data, or programming languages may simply forbid that sort of operations, right? So Quines are actually it's something that's possible in any Turing complete programming languages. It's like a direct consequence of Quines recursion theorem. Okay, Quines recursion theorem, it's like a pair of fundamental results about application of computable functions to it's like to their own descriptions. So to their own descriptions, in sense it's related to what to say a fixed points determined by enumeration operators, so which are like computable kind of a computable correlate. Okay, and the comfort part of Quine is that in all general purpose programming languages, Quines can be developed, like mixing the programming programs and data and all. For example, escaping codes inside strings of characters. Okay, so there is some difficulty, like the difficulty of programming these languages, like, and lengths can be reduced. These reducing the difficulty of programming these Quine languages to get the particular fixed point, and you're reducing the length because there's going to be a multiple recursive copying of data and code in this, so that can be reduced if the program, so the programming language that we use has features supporting structural reflection, right? That is like the ability of the language to provide complete reification. It's like complete reification when the program is run or executed. Okay, so reification means that the program is during the execution it can be encoded as data, right? In our cases, what we're gonna use for now, we're whichever programming languages, JavaScript, SQL, or whichever, we'll check with reflection features and not using them. Okay, yeah. Next thing about Quines. Quines take no inputs, right? And it prints its source code as output. Generally, Quines don't take any kind of input. They are allowed to, they are not allowed, I'm sorry. They are not allowed to step out of itself, which is like it can print its source code alone, but there can't be anything, any stuff like buffer overflow or getting out of the bound and print anything more than the source code. Very restricted. Okay, yeah. The advantages, obviously. The interesting thing is that writing Quine does not depend on any kind of stuff like being able to read the source file or able to represent, codes in several different ways and that sort of stuff. And it's like, let's just say we have a code to print its source, okay? We might be just having the binary to run and not the program, right? So we might not know where it is stored and all. So for Quines, they don't depend on any of this. It's like you run the program and you get the source printed, no strings attached. Okay. Yeah, so here we see different examples of and types of Quines. So first is constructive Quines. In general, the method, is used to create a Quine in any program from a language, is to have within the program two pieces. It's like code and data. I think I've mentioned before. Code and data. So code is used to do the actual printing. Okay, it's like in print hello. Print is the code part. Hello is the data part. Right. So the data that represents the textual form of the code. It's usually inside codes. Okay. Okay. So the code functions, by using the data to print the code, which makes use of the data. In sense, it's like it represents the textual form of the code, but it also uses the data processed in a very simple way to print, the textual representation of the data itself. Right. So it's like, summarizing, it's like code prints the data and the data has the code, which prints itself eventually. Again, the same reference to cells, where when it replicates, the DNA is in it also replicates as the data in the code too. Right. Okay, next is Ouroboros. In Ouroboros, the Quine concept can be extended, to multiple levels of recursion originating Ouroboros programs, or you can also call it Quine relays. These Quine relays or Ouroboros programs, which produce a chain of continuous files in different programming languages, eventually coming back to the original source code. Okay, it does it does its recursion and pops back to getting to the source. So the next is multi-Quines. Multi-Quines and Ouroboros Quines is not the same thing. There might be a confusion at some points, but it's not the same thing. Like multi-Quines when run normally, it's a Quine. But if it is called with a particular command line argument, it will print a different program, completely different program. Let's say it's a relative program. It's a relative program which is also a Quine, but then again in a different programming language. Okay, so the second one prints its own listings when run normally, right? But when it's run with a different command line argument, or let's say a fixed particular command line argument, it prints listing of the original program. That's the parent program, the first relative. Okay, so summarizing, multi-Quine is a set of two programs, or maybe two or more, which is able to print either of the two. Like it's a set of n different programs, like not just two, in n different languages, each of which is able to print any of the n programs. It can also be including itself, the parent Quine, according to the command line argument which is passed. Okay, so summarizing, it's like multiple recursive probability of Quines of number of languages, right? Okay, so another misunderstanding is polyglot Quines is a Quine that can be read, right, and is also a Quine in several different languages, right? So this might sound same as multi Quines, but no, it's not multi Quine. It's if you think about it, it pretty much fits in the definition of multi Quines. It can be a subset, but it's completely not a multi Quine. Okay, so polyglot Quine could be thought of generalization of a multi-coin. It does the same thing, but it doesn't need, command line arguments and all, of the programs that are identical or the child Quine or something like that. Right. So the next one is radiation hardened. I have no idea who's keeping these names. Radiation hardened, Ouroboros. Okay, a radiation hardened coin is like a coin that can be, have a single character removed and it still produces the original program, the original data that we inputted with no, like literally no missing characters. This seems like magic, like how you just lost a part of your body and again you come out with this complete part of your body. How does that happen? But yeah, it's that particular fixed point, as I discussed in Kleen's recursion theorem. It's that what makes, still makes it a coin. Difficult to get there, but yeah, fun. Okay, so eval coins. Something, some programming languages might have the ability to evaluate a string as a program. Not many, but there are, a few that has that functionality running. Okay, coins can take advantage of this feature. Val is actually one of the easiest way to write a coin, since it reduces the need to continuously copy the code and paste it, copy the data part, put it in the code, copy the code part and put it in the data, stuff like that. So like before we had a loop of code running data and data having code and all. As in the majority of the coins require 2 copies of code, as I said, one to be executed, one as data, right? So this can end up in doubling the length of the source code, making it harder to maintain, obviously. So trying to treat your code as data is often not possible, right? Treating data as code can be done in many languages using eval. As such, your coin basically consists of storing the main body of your coin in a variable, then evaluating that variable. That's pretty, basic kind of coin. Basic in the sense easy kind of coin. Okay, that's something that's more easier, and I don't know why it's in the classification. It's cheat coins. They seem self-explanatory, as I mentioned, on how coins don't need location or file or have the physical files accessibility and all to reproduce the source. So what is the point of not coding and directly getting the print of the source code? But again, those cheat coins fit perfectly under the definition of coins. It's a program that's run and it prints the output. So I'll just give it that acknowledgement to them. Okay, so yeah, 2 types. So source code inspect, it's like coins per definition cannot receive any form of input, including reading file, which means that a coin is considered to be cheating, right? If it looks at its own source code. In many functional languages, like numbers are self-evaluating. It's like when you print 1, it's like a 1 byte coin. If the last line of the program is returning, the returned value is displayed on the screen. Therefore, it's like in such programming languages, right, containing a single digit result in a 1 byte coin. Since such code does not construct itself, it's like a property. It doesn't construct itself. This is often considered cheating. So, boo, that's not a proper coin. I'll try to give a few examples or demos if time permits at the end of the talk. Yeah, okay. So we will take an example of this Python coin which prints itself. Okay, so as I mentioned, it has a code part and a data part. Here the data part is inside the codes. Okay, so and the rest is the code part which runs the whole thing and gets the code replicated as it is. All right. Let's just take a look at how this works. I'll start with the skeleton and then add on explain the. Oh. Okay. Yeah. Okay. So we give the variable no value, print it, nothing happens there, right? We give the variable the data part in string. Here we've given a variable with the first program we wrote to print that, and we call it recursively. That %r is to call it recursively. Again, usually it prints the data. Now we have to print the print function that should come out as output, right? So we add that data part too. Next is like we have to print this as string. We've added percentage s along. Now that we have added a percentage s, we have to have something that to print percentage s. So that's where we use percentage s to print percentage s. And there we go. We have a super easy Quine program example which prints itself, right? Next slide. Okay, so let's just say we have, this is a fun thing. It's not, again, what I said, it's not Quine SQL injection, but it's a type of attack. It's a type of injection in Quines. Okay, so let's just say we would like to add viral payloads to the Quine, but we do not want to harm its reproductive ability, right? So to achieve this, we can use introns, which are like pieces of Quine data that are not used to output the Quine code, but that are also copied when the data is returned the output. It's like non-essential Quine data, but the portions of data that are not used in the DNA to produce proteins. It's like you get 88% of your parents' DNA, but the rest is like, I don't know what rest is. I don't know biology, but yeah, rest is like it's useless, but it gets copied, right? It's not useless. It gets copied. So that's introns. Like it's copied, but it doesn't affect the reproductive ability of Quines. Okay, so yeah, as I said, Quines introns are reproduced along with the Quine, but they're not necessary to be to the self-reproducing ability of the Quine. Yeah, so therefore an intron can be modified without a reproductive penalty, making introns the perfect place to put SQL injection attacks, right? And yeah, that it doesn't contribute directly to the functionality of a Quine, as it plays no part in replication, but it just gets copied. Next slide. Yeah, let's see. Okay, so basic intron inject exam, how it responds is like, yeah, now this is an input method which takes input from users and injects it in Quines, right? So like it prints the Quine and also prints the input user gives. Okay, so it's waiting. So we have an intron and it's waiting for an input, right? Because for us, it's waiting for us input something because of the input function, it was waiting for us. So when we don't give anything, it just prints the whole Quine as it is, no inject part. It just does the self-replication and inputs it. Produces the replicated code, which is practically the main source code. So now that we give hello or something, right? What happens is it's printed along. As I told, the data is also printed along. It's like just that it's printed along with the Quine. Here, the function of the Quine is still doing fine. Just that we've injected a few bits which are practically useless in the replication process. The hello part is practically useless in the replication process, without which it can replicate also. Even if it's there, it can replicate also, but can be of great use in lots of gray areas. Okay, so now coming to Quine SQL injections. So basically, we've checked on SQL injections and Quines, right? Okay, and you put them in a box together, and we get Quine SQL injections. Like if it's a select name from table, the output is also select name from table. So the first thing will be like, where does this work, or like how is this gonna be useful? So I missed out one cool thing about Quines. Quine SQL injection, can all be like, yes, it has a very stern purpose which is concerning, but something about Quines is that we have competitions as to who can build the perfect kind of Quine, or let's just say radiation hardened Quines. It's like, who can construct a Quine without cheat Quines by omitting 2 characters, 3 characters, or n number of characters and print the parent Quine and stuff. But SQL injection Quines is more than just fun programming. Unlike other kinds of SQL injections, doesn't need any control on data, where it is or how it is put up on the table, the arrangement, or that sort of stuff. So even if it's a ghost table, or like even if the whole table is empty or returns null values for queries, these quines, right? It can still work. It's like, it's amazing, it can still work. So one thing is that it's not very common. Like, you cannot see this injection everywhere. It's not a severe bug or so. And why does it work this way? This can, without any dependence of that, actually can be understood from where it works. Okay, so here we can see that the resultant array of the query is, in the variable r, and they are checking if the resultant password and the password is same as the input we've given, right? So which is like, yeah, the right password to crack it. So basically what we have to give is that, so it should be something same as a resultant of the output of the input we give, right? So simple as that. Input a quine and check, the check will be satisfied since quine will produce itself and the authentication is done. But how does this work in an empty table of, something which responds null statements? Practically, oh, am I running out of time? Okay. Practically, this whole check only depends on if the input and results are, same and the authentication is done. Okay. No matter what's in the table, database or tables, where it is organized, we don't have to go to all that. Get the get the database name from schema, table names, column names, row names, and that sort of stuff. No, it's like a direct win-win. Okay, so coins are not, only the option here, right? Obviously, there's a lot of possibilities, SQL injection attacks that can be done here. Like, you can actually find the password through blind SQL injection, but it's like, as I told, it's pretty difficult. It's a darn long ride for an attacker. Let's just say it's attack if the row does not actually exist in the database or the password is a whole hash or something, right? So with true or false statements, how long can we sit? It's like, tiring, right? Yeah. Next possible attack could be like a union injection, right? So this is, this is not that tiring. This is, let's just say, you have, considering the info column of the information schema.process list, it it contains the currently executing queries, right? So we can make use of that. So MySQL process list actually indicates operations that are performed currently. It's like by the set of threads executing within the server. So the info part of the process list, like that, contains the statements the thread is executing, okay, or null if no statement is executed. The statement might be the one sent to the server or the innermost statement. Okay, so here we've used union select one admin database from information schema.process list. So this invokes the process list, and obviously it would print the same query executed as in the query we've given, inputted, right? So here we'll see how the process list works. So I'm running the statement to show how the full process list and info you see in the process list is printed. So I've written show process list and it's given, okay. Yeah, here in the info, it actually prints show process list. So it's like the process that's executed is run. I mean, process that has been run is executed as the output. Okay, so we hop on to this last demonstration part. That's Quine SQL injection. That's one of the easy thing on our hands now. So this might look disturbingly confusing, right? But I'll break it down and make it look easier. So here we are just recursively, replacing to put back to the same initial query, right? And the data part according to if we need a single quote or double quote. So if we need a single quote, we replace double quotes to turn back to single quotes, just like that. So I'll show you the breakdown. So yeah, here in this breakdown, when we pass the innermost data part, the replace statement will do its work, and we see that double quotes are converted to single quotes. In the second inner replace, we replace character of 36 of our last output with the new statement and end up bouncing back to our input program. That's like the source program, right? So I'll show up this query in the. This is basically our query run. So we've given the same input and gives the same output, right? So that's a Quine. We have the Quine with us. So let's try this demo. So here in this check, let's just try a basic attack and see how the server, responds to it. So we close the quotes and do a union select or something. Right. Okay. I'll show the demonstration directly. Okay. Yeah, here we can see that we close the quotes and do a union select one or something. It's like, when we give it as password. So basically the initial check on what kind of SQL injection can be used. If at all, we don't have the source code or authentication, know what the authentication or it's a black box testing, something like that, where what's going on is not known. So basically start off with something basic queries to put out, errors or hints which can help us, find what kind of injection can be done, error based or time based. So yeah, here we have the response as password equals 1, the one we gave in the query, right? So basically we got to make 1 equals to the inject query that we provide. Obviously our new favorite option, Quines. Here in the Quine query, we add the input a code, combine the union, and comment out the rest, right? So it's like we clear the authentication check easily with this Quine. Okay, we have to encode it. Yeah, when we give it as the password input, yeah, it's the same. What we gave as input is output, and we've cleared that. The authentication check is clear, right? So finally it's prevention. It's like our host said, SQL injection has been there. It's still going on, and it's not going to stop anytime soon. So I'm going to be talking about prevention and mitigation for the disaster management system. Disaster management, right? So one is input validation. The validation process, is aimed at verifying whether or not the type of input submitted is by the user is allowed. Right. So input validation is like sanitizing the inputs. It makes sure it's of the right type, right length, format, etc. Escaping user inputs, right? In that, always use character escaping functions for user supplied input, providing like each database management system. This can be done to make sure DBMS never confuses it with SQL statements provided by the developer. Okay, so yeah, next is like never connect your application to the database using an account with root access. This should be done only if it's absolutely necessary. If the attacker gains that accessibility, it's like the whole system, the whole integrity of the system is ruined, right? Yeah, that's administrative privileges. Okay, next is parameterized queries, which are like means of pre-compiling an SQL statement so that you can then supply the parameters in order for the statement to be executed. Okay, the user input is automatically quoted and the supplied input will not cause the change of the intent, right? So that's another prevention method that can be used. And next is like stored procedures. That requires the developer to group one or more SQL statements into a logical unit to create an execution plan. It's like, so whenever you need to execute a query, instead of writing it over and over again, you can just call the stored process, right? Okay, so that's that. We've ended this discussion. Is there any questions?
Wow, that's